Welcome again, and we are starting our second day with our first speaker. That's the expert from Nick's family, Yevhenii Yankovyi. Yevhenii, are you with us?
Hi there.
Hi there, Yevhenii. Okay, just a moment. We couldn't hear you just now.
Can you say it one more time?
Okay, while we are fixing the sound, I would like to tell that Yevgenii's talk will be about high availability. Yevhenii is a part of .NET Direction, and I'm eager to hear what kind of availability we will be talking about, actually. And while we are getting to this speech, I would like to remind again that we have two streams. That's one from Budapest and we have another from Ukraine. This speech will be more about technical talks, about .NET, project management and business analysis. And the other one from Ukraine will be more about business, but also will have more technical stuff as well. So,
I
Yevhenii,
see that we have
again with
Yevhenii
you.
back.
Yep, can you hear me now?
Hi.
Yes, we do.
Awesome.
Yeah.
Awesome. Good morning.
Hello everyone now. Yeah.
How was your mood?
I mean, I'm in a great mood. I mean, looking forward to start this presentation. So basically, I woke up and was thinking about like this presentation and getting ready for that. So yeah, I'm pumped.
Nice. Nice.
Great to hear.
We are also pumped to hear your presentation and our viewers as well.
Yes, and just before you start, maybe you can tell us a few words and to our audience, why did you choose this topic? How did you select it?
Yeah. I'd be interested.
Actually, that's the first part of my presentation. Why did I choose this topic? So like, I'm gonna talk about.
Alrighty, we will
this
not
a bit
steal
more.
this show then.
No spoilers then. Okay.
But I would like to answer that question if you don't mind, but with a short one. So pretty much I choose this topic because in all the projects I've been part of, I'm always talking about this and it's always hot topic. So I decided let's talk about this, not some specific things, some details, but generic stuff that I think would be interesting and useful for everyone.
Well, the hotter the better. Then basically the audience is yours. Good luck.
Have a good luck.
Thank you very much. Okay, so thank you, Anastasia and Yuri, for the kind introduction. My name is Yevhenii Yankovyi. It's you already know probably, and I'm a software architect. And I've been part of the Nix team for more than 10 years already. And I've been working, and I was lucky enough to contribute in multiple projects, like dozens of them, starting with small startups and just maybe consulting some different areas, components on how to do things better, up to the like huge enterprise businesses, which been around like for 10, 20 years, and they have well-defined standards, expectations, but they want to evolve, they want to do better, and they want to do more. And the reality is that requirements are changing all the time. And I'm not talking about business requirements right now. I'm talking about expectations from the user. And these days, we have a lot of different tools. We have a lot of different frameworks, clouds, etc., that helps us to build a solution with the high standards, but the expectations are going higher. So we're still going to have a lot of business to do here in terms of software engineering, and in particular, high availability. And all those projects I've been part of, that was always the question: is this system going to be highly available, and how do we achieve that? And sometimes business people ask this question on the first call, like during the introduction session, like, how do we gonna do that? What are we gonna do? And sometimes they think that high availability even more important than business features, or high availability is the business feature. But sometimes you might get a question from your manager like week before release, if the system is highly available. I mean, either way, you need to have answers for that question, because you need to understand the system should be highly available. It doesn't matter if the question was asked before or not. And that's your responsibility as an engineer. And again, I'm talking to engineers, probably it's not for managers, but for developers who works on the project, on day-to-day routines, designing systems, coding, testing, etc. So let's get started. So short plan for today. Let's start with definition. What is high availability? So we're going to talk about this later. And I want to emphasize that high availability is pretty abstract concept. So there are no simple answer for that. But still, it's a simple concept. But due to the nature of it, it might be complex. Then we're going to talk about point of failures and why failures are going to happen, and if they're going to happen, replication and redundancy, pretty much core thing when we're talking about high availability, data synchronization, infrastructure, and relation to software and the role of infrastructure. That's pretty much going to be obvious, but still we must talk about that when we're talking about high availability. Of course, pricing. If you want to do something, usually you have to pay for that, either in terms of development or purchasing software or just test it. I don't know. It's usually everything at the same time, but again, it's a separate topic. And we're gonna have some time for questions, so I'll be happy to answer any of them. So when we're talking about availability, and when manager asks you if the system is highly available, basically they're asking what is going to happen in case of system failure or individual component failure. And let's define the failure. Sometimes you might be overprotective and thinking about admit it to your manager or team members or the customer, whatever, that something can fail. It's like not professional, and you're gonna look bad when you're saying that. But you should not think that way. So the reality is that you should be professional and you should do your best in terms of making sure it's not going to fail in one or another way. But still, you have to admit that if something bad could happen, that's probably happened sooner or later, and you must be ready for that. And that's what defines you as a professional. And you must know how do you overcome the issue and how system going to behave, what you're going to tell users, or maybe you don't really need to tell anything. But like just bottom line, you must know what is going on and you must predict what will happen if something's failing. So let's just start asking those questions. What if something goes wrong? And this something, there are a lot of things that could go wrong. Now, let's start with the simple one. Like, what if you have network issues? You can't connect to this database for some reason, I don't know. Or just database server go down. I mean, you don't know why, but it just happens. Again, you can do everything to protect your system from happening, but it will happen. Or maybe on the logical level, your data integrity was compromised because of defect in the code that wasn't detected during the testing stages, and it just occurs some specific cases, but it actually happens. So what next? Or even application server goes down. It can be technical issue. I mean, you can have power outage. It can be just hardware issue. Your hardware can just burn down. I don't know why, but again, it doesn't matter why. It matters what you're going to do about that. And of course, software failures. Our servers goes with a lot of software and a lot of stuff we install into the servers, and we use a lot of different dependencies, third-party dependencies. We're using code. Sometimes it's hard to predict, and maybe even I would say impossible to predict all tiny little detail of a system. And what if shark is swimming in the server room? And I put that into the slide just because I actually observed this situation. Like around like 8 years ago, I had a conversation with a customer, and we were thinking about expanding businesses, and we because business was doing really good with our software already there, and we were thinking about, okay, let's scale, let's make it bigger, let's make more sales. So we need more hardware. And we were thinking, okay, let's go to the cloud, or let's purchase server and let's manage it. We started talking about money. And the customer decided that let's purchase server because we're going to spend money equal to a year of utilizing cloud services. So the logic was simple. After the year, you still have your hardware, you still have your server, but you don't really need to pay for clouds anymore. So that's why we decided to go that way. But unfortunately, after 3 months after purchasing the server, the server room was flooded because of, actually, I can't recall, it was like eastern shore of United States. It was some kind of flooding, and it wasn't actually shark, but fish was swimming in the room. Server was down for like 3 days. Of course, we had backups, but the reality is that we paid the price, and we still need to think about things like this, which you never can predict. And the answer to the question, what is going to happen if something goes wrong? The answer going to be one only right answer. And the answer would state that system should be available for users with no or minor disruption, and no data should be lost. And okay, and of course, like what is minor disruption? What is major disruption? That's up to the business. And of course, you need to take that into account as well, because like you have working hours, you have downtime hours, and like if user never noted that something goes wrong, like that's fine. But if you're providing services 24/7 and you have your users around the globe that's constantly consuming your services, that means you need to take care of that all the time, and you need to be ready for that as well. And high availability means so high availability states that system should be available all the time. That's pretty much it. So when we're talking about that, we need to think about 4 major concepts here. I have 3 on the slide, but the first one, the dear one, is failures are going to happen. You need to understand it. You need to admit that, and you need to talk about this all the time when you're developing and you're making decisions. And failures are going to be on the software level, hardware level, third-party dependencies, whatever. But you need to think about that. And even I want to emphasize some business feature which comes from the product owners or product manager may not scale, and they may not work good in the highly available environment. And you need to work with product managers to make sure you can wrap your business needs into high availability. So let's go one by one to the actual slide. So first of all, you need to think about avoiding single point of failure. So basically, you should not have any kind of components in which failure will cause the downtime of the entire system. Again, it could be software, hardware, it doesn't matter, network, power. You should duplicate everything. You need to make sure that failure will not influence that. And you can win time to, fix the problem, deploy more instances, etc. But you should not have downtime, so user will not absorb this. Of course, there are different practices. We're going to talk about this a little bit closer, but you the first thing you need to think about when you think about high availability. The next thing is design and failover strategy. Basically, this means how system going to behave when failures happen. So let's say you don't have single point of failure, but still failures are happening. Where data goes? How do you guarantee the data will never be lost? How do you guarantee that all the systems are operational? Again, a lot of different techniques can be used there. And again, it depends for the business, but you must think about this and you must know the answer for that. And of course, redundancy and replication, pretty much the answer to how to make system highly available, redundancy and replication. And that, I would say, maybe that's like the second topic of this presentation in general. And I'm going to talk about these three concepts during the course of the entire presentation. And probably I'm going to repeat myself a lot because they really interconnected to each other, extremely interconnected, and there are no separation of them because of the nature of the high availability in general. So let's start with the single point of failure, how it could happen. So first of all, I define points of failure into three categories. So usually there are two of them, but I actually think it should be three. The first one is physical. I mean, that's the simple one. You have your hardware somewhere and it's running and you hosted your software there. If your hard drive goes down, you lose everything there. Basically, not much you can do about that. Basically, you need to have another server somewhere that you can start offloading requests to there. And of course, we're talking about like that, about other technical issues that could happen, like network connections, power outage. So like perfectly, you should have separate lines for network and power, just in case. That's how you can actually protect your hardware. I mean, there are a lot of things about hardware, but I'm not going to talk about hardware a lot just because of modern way we're doing things. Basically, we go into the cloud and we not actually care about hardware that much. Or if there are already data centers, let's say private data centers somewhere, and you have to work with them, they're already defined, and usually they're dedicated people taking care of that. So it's not usually software development problem. And like we like to say, it's hardware problem, it's not software problem. And I'm talking about software here mostly. And going to the software, the next thing would be logical point of failure. It pretty much like defects or poor design which cause the failure. So for example, you can have just one simple defect which crosses the component somewhere, and your other system depends on that. I don't know, maybe some kind of data synchronization or just web server that face into the public database, whatever. This can be pretty much whatever you can imagine could happen. And that's why you need to test a lot. And also you need to think about introducing availability testing. If you don't doing that right now, you need to think about it. And availability testing is pretty simple as well. Basically, you need to start make your services fail, databases services, web services, Windows services, I don't know, any kind of processes you can imagine. You can start just stopping them down randomly under constant pressure and checking how your system behaves. Of course, you might start observing some increased latency, or maybe some defects, but again, you need to understand how the system is going to behave perfectly. You will not notice it at all. So that's would be a really high solution, and that's what we're aiming for. And of course, the category I've added is a vulnerable software design. And basically, it's not a defect, but it's pure design decision. And for example, it can be some kind of maybe not optimized or just pretty complex processes running. on the web server, for example. Or maybe if you want to embed your complex processing inside the web body of the web requests on the web server, which consumes a lot of memory, which consumes a lot of CPU, and just take a lot of time to complete. Maybe third-party dependencies, whatever, which will cause the system to consume all the resources when workloads are coming into the system and stop responding and then just crash. Again, a lot of things could happen. Maybe just bottlenecks or maybe poor decision in terms of database structure as well. So you can just make some requests work extremely slow, which caused failure. It's not the issue of high availability, it's just in general issue of the software you design, which will cause the availability issues. Also, I want to emphasize one thing that I'm talking about failures a lot here, and I'm repeating failure. But availability also means that your system available in adequate time. If you have to take like few minutes to respond to user requests, but everything's still up and running, I would not call that system highly available. Again, expectations of the user these days are very high. So you should respond quickly, and you should design your processing of your requests, your business logic in a way that you don't have these bottlenecks, and maybe you have some kind of request offloading or background processing. Again, depends on the business, but you need to make sure that your system there for the user. Okay, let's imagine the simplest design. I mean, probably the simplest design I can imagine. Maybe you can go without database at all, just application server, keeping everything in memory, but that by definition would not be highly available because server down, you lose everything. So you have to have at least database here and application server. Okay, let's add the question: what is gonna happen with the system if something goes down? For example, let's start with the database. Database go down. What do we need to do about that? So obvious answer going to be just add another replica for the database. So we have like just two instances, and we can just switch to idle replica in case if first one goes down, if active goes down, and start sending workloads to it. Pretty simple and straightforward. But now you need to start thinking about synchronization of those replicas, because if you have one and only working continuously with the data and you write in the data constantly to the database, you need to find a way to keep up on the other replicas, on the secondary idle replicas. And that's pretty complex thing. So here you need to you need to know the software user. For example, if you're talking about SQL Server, which is pretty common in the Microsoft stack, and I'm also working with Microsoft stack, I just want to emphasize, it doesn't have to be Microsoft SQL Server. Postgres works as well, but the idea is that you need to check your availability setting on the software you're using and the scenarios they provide. So I'm going to use Microsoft SQL Server as example here, but it doesn't mean it doesn't support it. And of course, synchronization could happen over the backups. So for example, you can just back up your database like by the end of the day. And if your database crashed, you can just restore restore your backup and just continue working. That's might be an option if your business work with that. I mean, if you're comfortable losing, let's say, day of data, or if you're comfortable with having this downtime until the database was restored, I mean, that could work, and that's pretty simple scenario. But in reality, business needs synchronization all the time, and you need to find a way of doing it. So in the SQL Server, Now, in the SQL Server, there are concept of Microsoft SQL Server always on availability group, which is actually designed to make sure your SQL Server instances are highly available, and like probably not instances, but your cluster, which goes with two kinds of nodes. So first one is primary node, which goes for read and write operations. So all operations, all operation you can do with this replica, and secondary replica, which stands idle, but can be used for read-only operations. So the reason they are separated purely because if you write to all the replica all the time, I would say it's practically impossible to make sure data synchronized across all instances. So it's extremely hard to do. So data-wise synchronization happens one way to the secondary replicas. Also, you don't really want to make sure you know which replica you're connected to, especially like when you need to switch to the second one. You don't want to write that code, etc. So another concept here in Microsoft SQL Server is availability group listener, which actually stands like pretty much like load balancer on top of your replicas, and your connection strings goes to availability group listener with definition whether you need read or write operations. And availability group listener will actually connect you to the required replica. Of course, when you design your system, you need to think about this as well, because like probably you're gonna want to have like all read and write operations all the time, but it's not the optimal way of doing this. So you might be thinking about actually offloading some requests to the secondary replica, so not everything go to the primary, and you can just start executing read operation on the secondary one. And that's pretty valid scenario. But again, it's required to think about your services and the way you interact with them and the way you connect to them. And of course, primary replica are going to fail. Sooner or later. And when this happens, availability group will actually switch to the secondary replica, make it primary. And now both write and read operation will go to the primary replica, and standby secondary replica, which are still there, will be synchronized with a new one. And of course, once your primary replica, which was like initially primary, goes online again, it will become secondary and will pick up the pace and start synchronizing back to it, and will stay as secondary. So your cluster is going to continue to be operational all the time, and you will continue be able to consume resources and access your data. And the key point here is synchronization, and you need to understand how it works. Actually, there are many different ways of synchronizing data, but most common two are asynchronous and synchronization. Asynchronous state that you have primary replica and secondary replica. And once you commit your operation, once you commit your transaction to the primary, because it's write operation go to the primary, it's later will be committed to the secondary. So you're going to have delay there. It's not going to happen instantly, sorry. And synchronous commit mode actually state that when you commit a transaction, it's going to be applied to the primary and secondary replica all the time. So you don't have to synchronize them later, but of course, you're going to have a little bit more of a latency introduced there, because you're not committed on one instance of the database, but to few of them. And actually, availability group supports up to 8 replicas, so you can have like 8 of them at the same time. So you need to understand the trade-offs here. So a synchronous way introduce less latency. So when you commit a transaction, it's just faster to do to the primary one. But possible data loss might occur, and you might be notice dirty reads if you go into read operation to the secondary replicas, because it's still not synchronized with the primary one, but you're already requesting the data. So some lag may occur there. So again, if your business works with that, I would prefer going with a synchronous mode, because latency, we don't want to introduce more latency, and we want to have a better experience for users. Synchronous mode on its side actually ensures that all the data is synchronized across the replicas. And in case of failover, your new primary replica, which goes from the secondary one, already has the data, so you don't have data losses, and you don't have lags when you read the data from other replicas. So data is consistent across the replicas. But of course, you have more latency there, because you need to make sure all the data is committed within the transaction across the nodes. Again, the decision to make, and that's up to you. So you need to understand your business needs. You need to understand what is more critical. I would say that in the enterprise environment, usually you need to have data consistent. No data loss should happen. But when we're talking about startups, this may vary, and like option might be different. But again, that's up to you. So let's get back to this simple design and just start thinking about next component here. Basically, this application layer and application server. And now let's do the same with the application server. We need to have standby replicas, standby copies of the application server. So it's actually ready to start consuming traffic if first one is failing. And this looks pretty similar as a database, but there are some differences. So first of all, you usually don't store data on the application layer, so you don't care about synchronization that much, except of some scenarios. But you still need to have these redundant replicas. You still need to have this redundant servers that's ready to pick up the pickup requests. And of course, you don't want to pay for the services which are doing nothing. So like probably you want to send your traffic to all of them at the same time. And if one of them fails, basically you don't really care, you notice nothing. And you consume all the resources, and you introduce more better user experience, probably less latency for users as well. And that's where load balancers usually came into play. And I want to emphasize the load balancer usually is not a part of high availability solution. That's more about balancing requests by some rules across the multiple nodes. But these concepts go side by side. And again, if you have all these replicas there, why would you just have them in standby mode? You want to send requests to them, and let's just use load balancer. But if we're talking about this, and we're talking about multiple application instances working side by side, and you never know in a practical sense which request, which user goes to which server, you need to make sure that your solution is horizontally scalable. So it doesn't really matter where requests go to which of the instances, and that's require you to design your software in the way it's actually horizontally scalable. So main reason of issues with horizontal scalability usually is the user data, user session, or maybe some kind of caching on the application layer. So let's imagine a scenario when we have like different users going to different nodes, and let's imagine the red user have their session on the first node, the green one on the second node, and the yellow on the third node. That's a common scenario that happens sometimes, and one server just goes down. For hardware reason doesn't matter, but it's not up and running. That means that all user data is lost. Okay, maybe not all, but at least session data. You might say, I don't care about session. That's fair enough. If you don't, I mean, you don't have an issue. If you do, maybe again some business features or maybe some I don't know, just some kind of requirement that needs to store some kind of data or cache some kind of data for calculation. Sorry for that. Sorry. Sorry, that was my dog and my ravens. I have two ravens here. I pick up them when I was driving to safe place, and now I live with the ravens. And sometimes they scream, and my dog starts barking on it. I mean, and they not enemies, but they just screaming on each other. Sorry for that. So yeah, let's get back to the topic. So the solution for that, basically, go with stateless application layer. Never save any kind of data on your application layer. If you do need to have your, I mean, some kind of user session here, just upload it somewhere. You can store in a database, or probably you're going to use Redis, some kind of memory data storage, which is pretty much industry standard right now. I didn't put it on the slide just to not overcomplify things, but the idea is just upload this data somewhere else and don't store the server. But perfectly, you would be nice to have all your application server, application layer completely stateless. So you don't really care about state at all. And one critical thing here that sometimes you might forget is that your load balancer should be highly available too. And that depends on the software you're using. Probably you're not going to develop your load balancer by your own, but you're gonna use something open source, for example, or maybe some enterprise license server. And check the license and check the feature it supports. So some of them on the open source versions doesn't support high availability out of the box, so you would have to take care of that. But on the enterprise license, actually it goes with high availability out of the box. So use it or not. It's again, it's decision for you to make and for your business partners, but you need to keep that in mind and not forget about it as well. Okay. In terms of session management, the general rule I prefer is that stateless is always better than stateful. So if you can make your services stateless, that's great, do it. If not, make sure you will not lose anything in case of failover. Make sure your application always horizontally scalable. Again, that's not part of high availability by the book, but usually the services which are scalable horizontally, usually they are highly available. It's just good practice. And also that means that your system is loosely coupled. So probably that's a good criteria to understand that there are not much point of failures, single point of failures. And of course, if you go in with the session storage and you need to have session and application layer, you need to keep in mind that you should not abuse the storage. I mean, usually it's pretty fast, like Redis store everything in memory, and you can just make calls to the storage and read whatever you want. But never store huge volumes of data there, because like, again, your Redis also might be your single point of failure as well. Don't share session between the applications. And I don't mean between the nodes of the same application, but if you have like 3 different services that technically might utilize the same data and they might be cached on the Redis, for example, don't do this. Don't share them, because that will introduce tight coupling across them, and failure or issue on one of the services may cause other services to go down, or maybe introduce some defects. So I'll delay them in case you're doing this. And don't make excessive requests to the your session storage. For example, never make requests in the loop because you're just going to DDoS your storage and it's just going to fail at some point of time. So basically, you're crashing your own services. Of course, we must talk about infrastructure redundancy and hardware, even taking the fact that in terms of software engineering, we're not really talking about hardware that often. But if we have to take care of that, we need to think about have redundant instances, additional instances that workloads can be transferred in case of something happens, power supply, network connection, and of course, get distribution in case of some disaster happens. And even if you don't really care about that because you're a software engineer and don't make those decisions and that's not your responsibility, you should always talk to your client and ask about that, because in general in software engineering, you want your services to be up and running, you want them to be working, and basically you're in the same boat with your system administration team. So you need to talk to them, you need to understand that everything works correctly, and you need to know the logistic of your infrastructure. And of course, these days we're talking about cloud, so probably all the new software will go to the cloud, and even huge enterprises that have been on a private data centers for a while, they also thinking about moving to the cloud, and they're doing this actively right now. And the best part about cloud services that most of them are designed to be horizontally scalable, designed to be geo-distributed. They have backups and high availability built into the design. So utilize that opportunity. So more managed service use for your application, probably going to be better for you. Of course, they go with additional price because usually you have to pay for that. And also, you need to emphasize that not all managed services are actually highly available, or maybe not all the features works with a high availability deployment. So again, you need to make sure that all third-party dependencies like clouds or like managed services actually work the way you intend to. So let's talk about the price actually. So you again need to understand that you would have to pay more for high availability. We're talking about redundant services, redundant service, redundant hardware, doesn't matter. Basically, that's mean we're talking about having more instances of the same, so you have to pay more. That's easy. And you need to design in a way and think in a way that you don't have to pay too much, but you still need to understand that you would have to pay something for that. And how much, that's up to you and up to the business. So you need to decide, like maybe having one redundant server would be more than enough, or maybe having one primary and secondary replica would be more than enough, maybe three, I don't know, it's up to you. Or maybe you want to make sure it's like always up and running and nothing actually gonna break it. The replication process usually goes through the cost. All the managed services usually more expensive. That's just developing something in terms of like deployment. So again, you need to check that, and you need to check how you utilize them. And again, going to the cloud and going to the overall infrastructure where you can horizontally scale everything and deploy. Probably you need to think about automation of it, because like you are probably not going to have a person who actually sits and deploys it manually. So again, it must build in the development process. It must build in the pretty much team dynamics. So it might require some additional investments. Of course, software licensing, like load balancers, probably going to take something ready out of the shelf. And that means that probably going to have to pay for the license. Again, that's up to you. That's up to the features you need to have on your load balancer. It may be simple, it might be complex. But again, pay attention to that. And of course, availability testing. So like I would suggest you to do this and plan before you release, and pretty much would have to invest into the team that going to do this. Okay. And key thing here that you must understand the price you would have to pay. The price you would have to pay for additional redundant instances, the changes in the software design, maybe the changes in the features that product owners ask you to have. But on the other hand, there are always price in terms of if something bad happens and your services are down, you're gonna lose your customers. So in the story I mentioned about like flooded server room, basically the server was down for 3 days and the customer business was in retail, and basically that mean there was like tens of marketplaces where he wasn't able to actually tell things and provide services. And the price you would have to pay for that, and that's additional price. So that's up to you. If you don't really care of that, maybe you should not have redundant instances. But again, that's not for me to make those decisions for you guys. Okay, regarding infrastructure, it's critical. You need to understand that it's critical, and no software can fix infrastructure, but it's not about infrastructure. And there are pretty common misconceptions that DevOps team going to take care of the software, going to deploy it, going to make sure it's working, but it's not. You have to think of your software design in the way it's going to be highly available, and you should give this instruction to the DevOps team how it can be deployed, and you need to work with them constantly. You need to understand your dependency in terms of software. Not all the packages you're using might support high availability. They might have some kind of issues inside, and maybe just software like for databases you use might be not that good in terms of high availability. So go to something you already know and already verified. And you must plan in advance, because infrastructure, again, it's a key. If you don't know where you're going to deploy it, probably you never would be able to answer what is high availability. Like, doesn't matter how good your system is designed. If it's deployed to one server and the server goes down, that's it. That's pretty much it. So make sure you know where you deploy, make sure you know and understand the infrastructure, and go for clouds if you can. And just pretty much I'm at the end of my presentation. Just short recall and summary on what I've been talking about, and key aspects you need to understand, you need to keep in mind is like go for stateless over stateful, or in general, think about your session management. And if you do need to have stateful services, go for a distributed session. Always backups, use backups, because even if you have synchronization, doesn't mean you need backups. And understand your failover strategy. Even if it's just simple backups, you need to understand it and clearly define that the strategy you go in. Think about redundancy and replication, how much you need and how you're going to do this. Of course, how much it's going to cost. Think about the synchronization and how your transactions are going to be applied. Make sure your system is always horizontally scalable. Think about request offloading in terms of removing like complex operations from the business critical points. And actually, I didn't mention in the presentation, but in order to make it happen, you need to make sure that failure detection mechanism also there. So like you need to collect telemetry from the service all the time, and need to make sure that your system reacts on the failure as well. Again, that's part of your failover strategy, but you need to keep that in mind too. So that's pretty much it. And as you probably noted, the high availability is very simple, but you need to constantly think about it from the start until the end, and you need to make sure your team understands it, your customer understands it, and I mean, it's easy to achieve. So don't forget about it. So that's it for my presentation, and I believe we have time for some questions.
Yes, we do. And as we know, you should already receive just a few of them, or maybe more.
Let's check the chat and see what's interesting to ask there.
Yep. Yep. So let's start for the first question. Should I think about high availability using some cloud environments like Azure? Does failure happen there? Yes, you should. Failures are happening. And the key thing is you need to make sure that you understand the services you're using on the cloud. So there are different models like platform as a service, structure, infrastructure as a service, and software as a service. And there are a bunch of managed service you can go with. Um, if you're talking about infrastructure as a server, you have like virtual machines you would have to take care of. You should think about failure there, and it depends also on how you're going to deploy, because you might like spin up your database server on the virtual machines, and you're going to take care of that. And if failures happens, and they will happen for sure, because even the cloud services doesn't provide SLA like 100%. That's actually good thing that I mentioned that you need to take a look at the SLA. Basically, it's number of nines, and you might evaluate like how long your service is going to be done probably, and basically you need to evaluate for your business. And on the other hand, there are managed services which again have their own SLAs, their own limitations and restrictions. So you need to take care of that. Also, you need to understand how it scales, how disaster recovery works, and you need to understand which features works there or not. I mean, it might be different, and also a limitation of the service by itself, because you might just hit the limits and the services will start throttling. So basically, you're not there anymore. So your service is not responding. So yeah, you should do it. But in general, clouds like Azure, AWS, they design for that. And if you just think about this and just double check everything you do, and you understand the strategy and how it works, it's easy to achieve. So you don't really need to do anything complex or design some kind of solution for that. Okay, the next question was, is better implement availability manually or use cloud features? How to choose between them and spend less money? So that's a very good question. So, and there are a bunch of questions actually. So first of all, when we're talking about developing something, let's say availability features, we need to always keep in mind that development happens in teams. You have software engineers, probably architects, managers, QA, DevOps, etc. And all these people actually have to get their payments, and they're gonna spend time, and etc. etc. So you already paid the price for the feature. And the question is, what is the price? First of all, if there are something already like this out of the box that you can maybe purchase for less than that, and would you be capable to develop and design such features in adequate period of time with the same level of quality that you can actually get from the vendors or cloud providers? If you do, go ahead. Usually you're not. And usually I would suggest you go to the some third-party vendors. Again, this can be software that you can deploy, maybe not cloud, but I know load balancers like Nginx, HA proxy, like that, or cloud features, of course. And I would bet that most of us and people watching this presentation, and in general software engineers, they not in the business of designing high availability solution. They're in the business of providing, some kind of important features. Retail, healthcare, whatever. And like, you don't want to waste your time on the design and such things, and learn how to do this and prepare a team to do this. And the customers usually don't want you to do this because there are already solutions. So just take advantage of that and don't waste time on that. Again, only if the business is providing high availability solutions, then you have to do this, of course. And regarding the price, how to choose between them and spend less money, you just need to go for the services you're going to use and understand the pricing model. So, for example, let's say, I mean, the common scenario, Azure Service Bus and RabbitMQ or Kafka, which RabbitMQ can deploy on your data center, and you have your Azure Service Bus as managed native cloud service. It's pretty easy to calculate the price. You just need to understand like how you're going to consume the service. So you need to understand how your users, how many users are going to come to the system, how many events are going to be pushed to the pipelines, I mean to the queues, and then you approximately can understand how much it would cost for you to actually use cloud service, and then you can like calculate the license price, for example, or price of support, and then you need to calculate the price of you would have to pay for your DevOps team to deploy it. Then you need to price for your QA team who's going to test it that it was properly deployed. And then if something goes down, you need to have a lower strategy. You need to make sure everything configured properly, and still the price. So again, it's up to you and up to the way you utilize your cloud services, because sometimes you can make one tiny mistake and that will lead to huge prices. Or maybe you use front service. Usually there are solutions on the clouds. I mean, you can find whatever you want, but just think how to optimize what you're doing. Usually clouds are good enough, and usually it's better to use something ready to go than developing and designing from the zero ground. But again, that's up to you and your manager to discuss. Better to have this conversation than not, and just clearly state the solution you're going for. I mean, either it's third-party providers, clouds, or you're going to take care of that. And if you do, then you have to design it properly and run the development process properly. Okay. In the diagrammed availability group, you introduce listeners, it looks like a single point of failure. It seems like we exchange on single point of failure for another. So what the benefit of such solution? That's a really good question. And actually, I mentioned on the different slide that your load balancer should be highly available as well, because that's single point of failure. That's a really good point. And I want to emphasize that I draw it the way it's like one single item, but it actually deploys to the availability group with the instances, with the nodes. So basically, you're gonna have three of them, and they all synchronize in the failover cluster. So if one goes down, you have still a bunch of them, and I believe it's go one per actually node there. So it acts like highly available load balancer for the database. But I want to say that's actually really good questions. That's the kind of question you to think about all the time and ask these questions. So how do you make sure it's actually going to be done, and whether we introduce another point of failure. Okay, so I missed one question. Okay, according to the CAP theorem, we should choose two options out of three: consistency, availability, and partition tolerance. From your experience, which option did you sacrifice the most, and how to select when the clients want them all? Clients always want them all, and in my experience, I would say it's not about selecting two of them and saying like the third one is not an option. The goal here is talk to the clients, the product manager, product owners, and understand what actually is more critical. So again, in my particular, in my experience, I would say that sometimes you have to trade data consistency for the availability, or maybe latency. In other cases, like, I mean, latency is critical. So maybe you don't care about data. I mean, data consistency at that level, and you can trade it. On the enterprise environments, basically data consistency usually is critical. So, I mean, you usually go for that. Again, usually just ask your business people. And again, I want to emphasize, it's not going to be like question answer thing. Probably you're going to have to spend month in the meetings just talking to people and say, okay, if you do this way, then these kind of issues which might happen. And if you go different way, these kind of issues is going to happen. So there are always trade-offs. Key thing here is to give clear picture to business people, and you must understand the business people not that good in terms of technology usually, because I mean they doing business stuff, they have a bunch of meetings, they're not coding and they're not in technology. So you need clearly explain them and then just talk about this. And then you decide what is better for the business. Maybe you even might have different scenarios of deployments, different scenarios of availability, etc. And as I mean, in the recent projects we had different deployment options. Like you can go in your private data center, you can deploy to the cloud, you can deploy to the Kubernetes. Doesn't matter, cloud or on data center, or even you can have like a simple deployment to the one server, and it's gonna work. Of course, it's not available at all because you have like one single server, and probably if it's failed, nothing gonna work. But if they don't want to have additional complexity, they don't want to pay the price, etc., they can choose that option. Again, you need to understand your customers, your clients, and your business partners, and then make this decision. Hope I answered the question. Actually, I want to emphasize it's really good questions. What are the names of your pets? Okay. Right now I have two dogs. One is a pit bull named Monterey, May short. The second dog name is Thor, but not like Thor, the god of thunder, but Thor like tort, cake on English. And also I have 4 cats right now, like 3 cats are mine, one is my sister, Horatio, Kane, Zlatan, and Lisa. And my sister cat is Mamba. And 2 ravens right now, which is not sure how to translate it properly, but one first name is Montirovka and Kuvalda. Don't know how to say Kuvalda, but Montirovka is going to be crowbar, and basically that's the reason of the name. I believe it's all my pets right now. So it looks like we don't have questions anymore. Thank you very much. And I think that's it.
Yeah, thank you for your speech. There's a bunch of family members over there, including people and not also people. Well, I really loved your speech. Especially I love that talking about availability, you also partially covered other topics like maturity, recoverability, and fault tolerance. And I can't emphasize more that we really should talk more about non-functional stuff when we're talking about the software.
I agree.
Yeah.
Yeah.
So
yeah. If you don't mind, let just another thing that like high availability is pretty much basic requirement for any software these days. And even like if nobody asked that question, like or defines this as requirements, like every software engineer, doesn't matter junior, senior, architect, whatever, needs to understand its default requirements. So
yet
it's always should be
somehow
there.
they tend to forget about this. So that's great that you decided to remind us all about such important stuff.
Thank you.
Yeah.
Yeah. And
Thank you very much.
how did you like the questions? How do you feel about your speech?
Yeah, I think it went well, except when my dog started barking.
Oh, that was very sweet,
uh,
actually.
Maybe he also
Yeah,
wanted to say
actually,
hi.
Definitely. I have cats around here, and I was lucky that it was just my dog barking. Um, so yeah, overall, there are a lot of things I would like to speak more about and maybe go into details, and especially some low-level details in some particular technology, because um, it's hard to imagine when you have like few projects over the course of the years with the same stack, I mean, identical stack, and usually need to think about things differently, and availability solution could be different as well. Um, so yeah, and I like especially talking about like Kubernetes deployments, clouds. That's all the topics for different conversations. But in general, I really like talking about high availability, and yeah, I really enjoyed it. And I would say the questions was really great. I would say the right questions, the question I would like to hear. So that's real nice.
Awesome.
So thank you everyone.
So it looks like we should book the slot for the next conference, because there are a lot of topics that you can cover, and we are super excited to hear about all of that as well.
Yes, and now we wish you, your family, and all the pets you have good luck, stay safe, and we were happy to have you here.
Yeah.
Thank you very much. See you later.
Thank you. Bye.
Bye.
От зараз буде, так?